Simplify and express each of the following in exponential form. A is 2 and its exponent is 0, and 3 plus 3 with the exponent 0, and 4 having its exponent as 0. Now 2 to the 0 power, 3 raised to the 0 power, and 4 having its exponent here. Now we know that whenever we have an integer a that is non-zero integer, it cannot be equal to 0, and if it has its exponent as 0, then it is actually equal to what? 1. So from this is 1, this is also 1, and this is also 1. So you get 3. Same thing here, this is b. In this you are actually multiplying them instead of adding them. So this is 1 times 1 times 1, and you get what? 1. In this one we have 3 is its exponent is 0, plus 2 exponent is 0, then times 5 exponent is 0. So this becomes 1 plus 1, right, times 1. So you get 2 times 1, so you get 2. Now in this fourth one, here we have 4 to the 5th power times a to the 8th power times b to the 3rd power, right? If there is no multiplication sign between the two variables, if there is no sign of any operator between two variables, it means that is actually what? Multiplication. So this can be written as 4 to the 5th power times a to the 8th power times b to the 3rd power. This is 4 to the 5th power times a to the 5th power times b to the 2nd power. Now this can be grouped together like 4 to the 5th power times divided by 4 to the 5th power, then multiplied by a to the 8th power divided by a to the 5th power multiplied by b to the 3rd power divided by b to the 2nd power. Now this becomes 1 because these both are actually equal, that is the two powers are actually same, 4 to the 5th power. So this becomes 1 times, this is a to the 8th power divided by a to the 5th power. Clearly these two powers, that is a to the 8th power and a to the 5th power, have the same basis, they have the same base, that is a. So the second law of exponents, from that this becomes a, that is a base, then simply subtract the exponents, then times, here b to the 3rd power divided by b to the 2nd power, again the two powers, that is b to the 3rd power and b to the 2nd power, these both have the same base, that is b. These two have the same basis, therefore this becomes b, and the exponent will be 3 minus 2, using which law? The second law of exponents. So this becomes a times a to the 3rd power times b to the, if this is coming 1, so we don't need any exponent here, or if you want you can simply put it, but we simply avoid putting 1 as exponent. So this becomes a cubed multiplied by b, or simply you can write it as a cubed b, right? This can be written as this one. True or false, and justify the answer. This is 10 multiplied by 10 to the 11th power, and is this equal to 100 to the 11th power? Now this is actually what? 10, and the exponent is 1, right? If there is no exponent, it means that it is actually 1, and this is 10 to the 11th power. Here in these two powers, that is 10 and 10 to the 11th power, the bases are actually the same. The base is 10. The bases of these two powers are 10. So this, using the first law of exponents, it becomes, write the base, that is 10, and simply add the exponents using the first law of exponents. And this becomes what? This becomes 10 to the 12th power. In this case, this is 100 to the 11th power. Now, you have to first convert it into the base, having its base 10. So this 100 can be written as 10 times 10, right? And this is 11th power. Now this is 10 to the second power. This 10 times 10 can be written as 10 to the second power. And this is 11th power. Now this is the case of the third law of exponents, that says that if a power is raised to a power, here 10 to the second power is further raised to the 11th power. In that case, you first write the base and then multiply the two powers or the two exponents here. So this becomes 10 times 10 to the 22nd power, right? 10 to the 22nd power. Now clearly this is 10 to the 12th power and this is 10 to the 22nd power. That is, here exponent is 22 and here exponent is 12. So clearly this will be greater and not, this is not equal to. Therefore this one is actually false. This is not true. In this B1, we have 2 to the third power times 3 to the second power. So this is 2 to the third power times 3 to the second power, and this can be written as 6. This 6 can be written as 2 to the third power. Sorry, 2 times 3. I'm really sorry. 2 times 3. This 6 can be written as 2 times 3. And this is 5th power. Now, if you solve this, this is what actually? This is 2 times 2 times 2, that is 8, times 3 times 3 is 9. So you get 72, right? In this case, if you solve this one using the fourth law of exponents, that says that if you have two powers, let's say a to the mth power times b to the mth power, that is, the exponents are the same. The exponents are the same. So in that case, this can be written as a times b to the mth power. That is, this is the fourth law of exponents. Same thing can be applied in a reverse direction. That is, if this is a times b and it is raised to the mth power, so this can be written as a times a to the mth power times b to the mth power, the fourth law of exponents, right? We are viewing it in a reverse order. So from this one, it becomes 2 to the 5th power and times 3 to the 5th power. Now 2 to the 5th power is what? 2 to the 5th power is actually 32, right? Times, now this is 3 to the 5th power. I can write 3 to the 5th power as 3 times 3 to the 4th power, right? We can write it as 3 to the 3 times 3 to the 4th power. Why? Because if you solve it using the first law of exponents, this is actually what? 3 to the 5th power only. So if I write this 3 times 3 to the 4th power and just focus on only these two multiplication, the multiplication between these two numbers, this gives you what? This gives you 6 and 96. So this is actually 96 times 3 to the 4th power, right? Now look here, why I haven't completely simplified this 3 to the 5th power, just to save our time and energy, because we can see here by simply multiplying 32 and just taking 1 3 out of it, we are getting actually 96. That's in any case greater than 72, right? So there's no need of further multiplying, because simply by 96 is already greater than 72, and if we further multiply this with 3 to the 4th power, our number will be much greater than 96. So we don't need that. Here 96 times 3 to the 4th power is clearly greater than 72, and it is actually not equal to therefore these two actually are not equal to, because it's coming as 72 and it's much greater than even 96. So this is also false. Now here 3 and its exponent is 0, that is power is 0, and 100 is raised is having its exponent 0. Now a raised having its exponent as 0 is actually equal to what? 1, where a is any integer other than 0, any integer other than 0. Then from this is actually what? 1, and this is also what? 1. So clearly 1 is equal to 1, and this is actually true. In this one we have to simplify. Now if you look at this 25, and this is 5 squared, this is t to the 8th power. Now clearly what we can do is write this 25 as 5 times 5, and this is already 5 to the 2nd power. Always think of such problems, to write them in the form of exponents. If you want to, go through counting this, that is 25 times, then again 5 times 5, that is 25 into 25, that will take a lot of time and energy. So think of such problems always in the form of solving in the form of exponents. So 5 times 5, this is 5 squared, and this is t to the 8th power, okay, and this is 10 to the 3rd power. I want to write this as 2 times 5, and this is actually 3rd power, and this is t to the 4th power. Now if you solve this is actually what? 5 to the 2nd power, and this is already 5 to the 2nd power, and this is t to the 8th power, right? Now this can be written as 2 to the 3rd power and times 5 to the 3rd power. Why? That we have already discussed in our, in this previous problem here, this one. So 2 times 5 having 3rd power is can be written as 2 to the 3rd power times 5 to the 3rd power and times t to the 4th power. Now this is actually what? 5 to the 2nd power and times 5 to the 2nd power. If you apply the first law of exponents, that says that if the bases are the same, then you simply write the base and then add the exponents. If you have the same base and you are multiplying them, so this becomes 2 plus 2, the first law of exponents, and this is t to the 8th power, and this is 2 to the 3rd power times 5 to the 3rd power times t to the 4th power. Now this is what? 5 to the 4th power times t to the 8th power, and this is 2 to the 3rd power times 5 to the 3rd power times t to the 4th power. I can write this as 1 times 5 to the 4th power times t to the 8th power. I have simply introduced a 1 and I have multiplied this. Multiplying 1 with any number will not make any change to the original value or the number. And this is 2 to the 3rd power times 5 to the 3rd power times t to the 4th power. Now I can further write it as, simplify it as 1 and 2 to the 3rd power times 5 to the 4th power divided by 5 to the 3rd power times t to the 8th power and t to the 4th power. Now this is what? 1 and divided by 8, right? 2 times 2 times 2. Now multiplied by this 5 to the 4th power divided by 5 to the 3rd power. Applying second law of exponents, that says if you are dividing two powers having the same base, having same bases, if they have the same base, that is 5 in this case, so simply write the 5, the base, and subtract the exponents, then times this is t to the 8th power and this is t to the 4th power, again applying second law of exponents. Why? Because we have these two powers have same base, they have the same base, so this is t and then 8 minus 4. So I'm writing it here now. This becomes 1 to the 8th power, 1 over 8, 1 divided by 8 times 5, and 4 minus 3 is actually what? 1. So we don't need to write exponent in this case. This is 5, and this is t to the 4th power. Right? Now this can be written as 1 times 5, because this is what actually 5 over 1, and this is actually this way. So this becomes equal to this one, 8 times 1 times 1. So you get 5 t to the 4th power divided by 8. Right? 5 times t to the 4th power divided by 8. Let's solve this second one. In this case, we have 3 to the 5th power, then 10 to the 5th power times 25. So 3 to the 5th power, keep it as it is, because we don't want to further simplify it, because we can use it straight. This is 10, so write it as 2 times 5 and to the 5th power, and this is 5 times 5. We can write 25 as 5 times 5. So this becomes, now this is 5 to the 7th power, keep it as it is, and then this 6 can be written as 2 times 3 to the 5th power. Right? Now you can see that what's the importance of breaking them in 2 times 3 and 2 times 5, because now you can clearly look that we have here one exponent of 3 to the 5th power, and we can make another exponent of 5, and another exponent of 5 is here. So this is 3 to the 5th power. Now again 2 times 5 to the 5th power. If you have a times b to the mth power, this can be written as a to the mth power times b to the mth power, and using which one? Using the fourth law of exponents we have discussed here. So this becomes 2 to the 5th power times 5 to the 5th power. This is 5 to the 2nd power. 5 times 5 means 5 to the 2nd power. This is 5 to the 7th power, and this is again the same way as we have done for this one. 2 to the 5th power times 3 to the 5th power. And how? Using the fourth law of exponents. Always remember, whenever you are writing in examination, while you are giving exams, always put all the details. Like, you have to mention which law you have used, otherwise you can lose your marks. So here it is 3 to the 5th power times 2 to the 5th power, and this is times, if you look at these two, these are actually what? The first law of exponents, that is, write the base. The bases are the same, so write the base and simply add the exponents. Then divide by, this is 5 to the 7th power times 2 to the 5th power times 3 to the 5th power. Now here, this is 3 to the 5th power times 2 to the 5th power times 5 to the 7th power, and this becomes 5 to the 7th power times 2 to the 5th power times 3 to the 5th power. Now I can write this as 2 to the 5th power times 3 to the 5th power times 5 to the 7th power in an increasing order, like 2, 3 and then 5. Here I can write it as 2 to the 5th power times 3 to the 5th power times 5 to the 7th power. Now this is 2 to the 5th power divided by 2 to the 5th power and times 3 to the 5th power divided by 3 to the 5th power times 5 to the 7th power divided by 5 to the 7th power, right? This comes as 1, and times this also comes as 1, and this is also 1. So your answer is 1.